right, here's the second video. Don't be afraid to ask questions either. So finding the common denominator. When I'm dealing with rational expressions that I'm adding or subtracting, you know, rational means ratio, which means fraction. So I'm adding or subtracting fractions, right? And adding or subtracting fractions, I need a common denominator. So, Robbie, what is my common denominator between these two fractions? 10. Now, how did we get that? We just multiplied the two denominators together. Now, that's not necessarily my lowest common denominator. It could be, but it's not necessarily. But the bottom line is, it is a common denominator. Not asking for the lowest. I'm saying find an A. Should say A, not the a common denominator. So all I need to do is multiply these two values together. So x times x minus 5. If I multiply those together, I got to distribute, and so I get what? Yep, 5x. That's my common denominator. The same way we got 10 up here is the same way we get x squared minus 5x. Now this may look tricky. It's not. It's the same exact thing. It's just you got to remember what happens when you multiply exponents that have the same base. What's my exponent right here? What's my exponent right here? 1. No number as an exponent means it's a 1. So now let's multiply them. I got 5x times x squared plus 6. Yep, distributive property. So what's 5x times x squared? 5x to the third, or 5x cubed. Because that's a 1, that's a 2. Add them together when I multiply because the bases are the same. And then plus 5x times 6 is 30x. And that's my common denominator. So that's all you got to do for that. Any questions on that? All right, keep it moving. All right, I look at these. Oh my God, for multiply this, oh my God, I gotta do Bob's method. Not necessarily. The first thing I want you to notice is that I can do some factoring here. I can use the greatest common factor. What's the greatest common factor between those two terms? 3. I can divide a 3 out of this, and I can divide a 3 out of that. Does everybody see that? What about here? I can divide a 7 out of both of those terms. So that's the first thing I'm going to do. I'm going to divide a 3 out, and I'm left with x minus 2. I'm going to divide a 7 out, and I'm left with x plus 4. And now I look at what I got to multiply. So I'm multiplying these two things together, and what can y'all see? Say it. Well, yep. Oh, I thought you was going to say cross cancel, but yep. I can cross cancel because this and this cancel each other out. And then this and this cancel each other out. So I am left with 3 over x. Now, I'm sorry, 3 over 7. The other thing is this, though. Did we talk about exclusions? Because we should have. So let's go back to before we cancel. What are my exclusions? What can't x equal? If this is my denominator here and this is my denominator here, I got to think, what will make x plus 4 equal to 0? Negative 4. And what will make x minus 2 equal to 0? Positive 2. Yes, you need to. I'll make sure I put it in the instructions because I didn't think about doing it here. That's why I skipped it. So, it happens. So anyway, I look at these. Man, oh my God, so many numbers. I can factor these and do something similar. So what's the greatest common factor for this first top part? Say it again. So I'll pull out a 5 and I got x minus 3. Uh-oh, come on, man. You make me look bad. 3. What can I pull out on the bottom? So I pull out a 7 and I'm left with what? X plus 2. And now I need to see what's up over here. What's my greatest common factor between those two? So I pull out a 9 and I'm left with what? X plus 2. And then down here, what do I got? I can pull out what? 2 and I'm left with x minus 3. So what are my exclusions? What can't x equal? I look right there, x plus 2, so nope, can't equal negative 2. What about here? Positive 3. And so now I can start doing some cross canceling. You look at the denominator and what values of x will make that whole thing 0 when I multiply this all out. See, the numbers aren't going to make a difference in getting it to 0, but variables are because I'm plugging them in. 7 times x plus 2. Well, if x equals negative 2, then that's going to be 0. And then the whole thing is 0. And so I'm going to cross off this x minus 3 and this x minus 3. And then I'm going to cross off this x plus 2 and this x plus 2. And so I'm left with 5 over 7 times 9 over 2. Now I'm looking at the numbers to make sure I can't cross cancel or anything there. I can't, so then I just multiply. That's 45 over 14. And that's my final answer. Does anybody got any questions on that? All right. Divide and simplify. Divide. What are my 3 letters for dividing? K, C, F. Keep, change, flip. And that's what I'm going to do to both of these. All right. All right. So y'all go ahead. I'm going to continue. So with KCF, keep, change, flip, the first fraction is going to stay the same. Then I change my division sign to a multiplication sign, and then I flip the second fraction. All right. So now I look at these and I want to simplify. I found something that looks like it's the difference of squares. So I need to handle that. So that's going to be, I'll keep 6x over here, times, that right there is the difference of squares. So I got 2 parentheses, plus and minus. If I take the square root of x squared, that's x and x. And then I take the square root of 16, that's 4 and 4. And then I look down here, that is not the difference of squares, that is greatest common factor. So I'm going to factor out a 4. So if I pull out a 4, I've got x minus 4. And then I got 4x. So now I'm going to rewrite that. 6x over 4 times x minus 4 times x minus 4 times x plus 4 all over 4x. So now I need to think of my exclusions. What can x equal? So I've got this little set of parentheses where x minus 4. What value of x can I plug in to make that 0? A positive 4. So we can't have positive 4. And then here I got 4x. What value of x will make that 0? Well, 0. So I can't put in 4 or 0. So now I can start simplifying. I've got x minus 4 on the bottom and x minus 4 on the top, so I can cancel those off. On top of that, though, besides just canceling stuff that I can see, I can also, well, I can cancel, my fault. Let me go back and cancel off the x's. So I've got an x up top and an x on the bottom. They cancel each other off. And so now I've got 6, well, I'll just rewrite it. I've got 6 over 4 times x plus 4 over 4. Well, I can simplify 6 over 4. Both of those can be divided by 2. So that's going to become 3, and that's going to become 2. So now I just multiply straight across. I'm going to have 3 times x plus 4 over 2 times 8, or 2 times 4, which is 8. And that's my final answer as long as x doesn't equal 4 or 0. Now you could multiply 3 times x plus 4, but I'm not going to, that's not a big deal. So in that case, the answer would be 3x plus 12 over 8. Either one of those answers is acceptable. So now B. B's a little trickier, but I start off in the same line. I've got keep, so x minus 2 over x squared minus 1. Let's write that a little nicer. And so now I change, so that becomes a multiplication sign, and then I flip. So that's x minus 6 over x squared minus 4. So now I look at that, and I think, what kind of factoring can I do? You know what? I see some difference of squares. X squared is a perfect square, and 1 is a perfect square. So I'm going to rewrite that. X minus 2 on the top, and on the bottom here, I'm going to have x plus 1 times x minus 1. Times. Now over here, I've got another perfect square. So I'm going to have x minus 6 on the top, right? And I'm going to have x plus 2 times x minus 2. Where did I get those numbers from? I took the square root of x squared, which is x, and then I took the square root of 4, which is 2, and plus and minus. So now I need to think about my exclusions. So what can't x equal? Well, I've got x plus 1 and x minus 1, x plus 2 and x minus 2. So what that tells me is x cannot equal positive 1 or negative 1, positive 2 or negative 2. Because if x equals one of those four values, I get 0 for one of these pieces. And because all of these things are being multiplied, that will give me 0 in my denominator. And 0 in my denominator gives me division by 0, which I can't have. So now finally, I can do some canceling. I've got an x minus 2 up top. When I cancel and there's nothing left, there's a 1 that's left over. Okay, like when you're adding or subtracting and you take away, 5 minus 5, there's 0. But when you're dealing with fractions, you're dividing. So I've got x minus 2 divided by x minus 2, that's 1. So when there's something left, I just cancel it off and I don't think about it. But when you cancel something off and there's nothing left, there's pretty much a 1 left over. So now I'm going to multiply all that out because there's no more canceling to be done. And so I'm going to end up with x minus 6 over x plus 1 times x minus 1 times x plus 2. Now you could multiply that all out. I'm not going to require it. It's fine. So that's my answer, with the stipulation that x cannot equal 1, -1, 2, or -2. And that's how you do that. And that's page 2.